Okay, so today what we're going to do is we're going to try to understand what bivariate data sets are. And what a bivariate data set is it's just a data set that has like two variables with it. So like yesterday, we compared only single data sets to each other, where we only looked at their box plots. But today we're going to see how like correlated are these things together. Like if we looked yesterday at how much money you made compared to what rating you got, that would be two variables in the same data set we're looking at compared to just looking at one of the variables at a time. So a couple things. I said how correlated the things are. Here's what correlation means. Correlation is a measure of how strongly linearly they are related to each other a lot of times. We could use other types of graphs, but it's how close that relationship is, and generally we mean linear. This thing is unitless. It doesn't have any kind of unit with it. We don't say it's like 0.95 correlation strong. Like it doesn't have a unit with it. It can only be between -1 and 1, and that's because this is kind of like a percent of how close the dots are to the line. So percentages can't be above 100%, and they can't be below, well, they can't be above 100%. So because it can't be above 100%, 100% in the positive direction means up, and 100% in the downward directions means negative. Zeros if there's not really any kind of line, or the line looks like this. I don't really want a laser pointer, I wanted a pen. So if the line is flat. So we'll look at these things and kind of see how this stuff works. As you can see, these are kind of how the correlations go. -1, it's going down, and all the dots are really on the line. This one, -6, so like 60% of the dots are really kind of close to the line, and it's going in a negative direction. 0 and 0, so both these are 0, even though this one, all the dots hit the line, but they're just flat. It's not really a line going up or down. So this one's 0 because it's clustered around the middle and there's really no correlation. Same thing here. There's really no correlation. These things aren't really related to each other. This is really strong positive, and this is what a weak cluster would look like. So we'd call these strong negative, strong positive, moderately strong negative, weak positive, no correlation, no correlation. These are obviously linear relationships, and sometimes they're going to curve. So if they curve, we don't really worry about this or use this. Strong relationships are close. Weak relationships are more spread out. And you can kind of talk about moderately weak if you're not sure how close it is to the line or how strong it is. And obviously no relationships are sideways. Okay, so these variables, we're going to think if they're correlated, weight and height. And you can see that generally as the heights go up, the weight also goes up, and that kind of makes sense just in reality. Like the bigger I am, the more like my bones are going to have to weigh more. Like at some point you have to have more weight with more with more height. As you can see, though, not everyone is the same weight, and that's because you can be heavier or lighter depending on a whole bunch of other factors. So the other factors kind of stray these dots away from the line perfectly. So they are correlated, but it doesn't mean these things are exactly true. These, you can see baseball money spent versus wins, and you can see these things are kind of correlated with each other. Like the more money the teams spend, we can kind of see this line kind of going up here. If I could draw a straight line with this tool, but we can kind of see that it kind of goes up in this straightish line. So generally, the more money you spend, the more wins. Now it's not perfectly correlated. Now, so here's the big idea that kind of comes from this. So we can see these two things are correlated, but that doesn't mean one causes the other. And that's why, like, even in this example, the dots are not perfectly on the line. It's because just because two things are related doesn't mean they cause each other. Like height doesn't necessarily cause you always to weigh more. Sometimes it does, but weight has other factors like genetics, diet, exercise. There's all these other things that kind of build into it. So just because someone weighs more doesn't mean they're really, really tall. And same thing here. Just because some team pays more doesn't mean they win a lot of games. And you can see this is a really weak correlation, like a 10. It's pretty weak. This gets into this idea again that correlation doesn't cause anything to be true. And there are a lot of times there's these third factors that you don't think of. Like they have the statistics with global warming and number of pirates, and we can see that as the temperature has gone up, there has been less and less pirates. So you might go, oh, if we have more pirates, maybe the temperature will go back down. And the answer to that is, no, that's ridiculous. Like technology has affected both. Like we have more technology, which makes it not as easy to pirate because you can't just get any old boat and try to take over a boat anymore. Like boats go really, really fast. So you need really, really good technology to take a boat, which means you probably need some kind of government funding. So just any old person become a pirate is not as likely anymore. And because of some of those technological advances, our temperature on Earth may have rise due to some of those things we've done. But these things, just because they're correlated, doesn't mean one is causing the other. Same kind of thing here. This is one of my favorite ones. The murder rate versus the amount of people that use Internet Explorer. So the murder rate in 2006 was a lot higher, and Internet Explorer's usage was a lot higher. And as it goes down, so does the amount of murders that go down, so does the amount of people that use Internet Explorer. So you might go to yourself, well, is people getting so frustrated with Internet Explorer that they got so mad that they killed somebody? No. It just means our technologies got better. Internet Explorer was a bad operating system, or a bad web browser, and so because it wasn't as good of a web browser, there's other options that came in that were better, so more people started using that. And because technology has gone up, our crime prevention has also gone up, and I think our society changes has helped decrease the amount of murders that have happened. So again, this thing is just another technology causation that you, like, just because these things are correlated, it doesn't mean one is causing the other. You don't get to know that unless you perform a research study. We can see some scenarios here that are fun to think about, like scenario 1, ice cream sales increase, so does the shark attack. So these things are correlated, but again, one doesn't cause the other. What causes both is summer. More people are in the water during summer, and more ice cream sold during the summer because it's not as cold. Scenario 2, strong correlation between cavities and vocabulary size. But again, like the correlation there is, the longer you live, the more likely are you to have cavities, and the longer you live, the more likely your vocabulary increases. 2003, Phoenix being the third highest city. They suffer from a ton of asthma, so therefore living in Phoenix and Tucson, you're more likely to have asthma. Well, yeah, but just because you live in those cities doesn't mean you're going to have more asthma. That deals more with probably climate, like it's in a desert. So if you were born somewhere else, probably don't suffer from asthma. Just because you moved back there probably doesn't mean you're going to increase your risk of having more asthma. Number 5 is actually a really big deal because there's people that jump on this bandwagon. So they see nations that add fluoride to their water have higher cancer rates. So a lot of people think, oh, well, that means fluoride is causing cancer. And that's not true. It's because nations that don't add fluoride to their water are generally underdeveloped countries, which means a lot of their citizens are dying before they could get cancer. If you waited long enough, some more of those citizens, if they didn't die earlier, may have developed cancer. So you have to be really careful with this correlation causation thing. Just because two things are correlated doesn't mean we understand how they're caused. It just gives us some insight that there might be something there that is causing something else. So as you go through this, do not answer anything that says, oh, these things are correlated, that means this causes this. Like, no, never. It just means that we get some idea that maybe something helps us figure out what is causing something else. And that normally is done with very good research and very good experiments. If you have any questions, let me know.